Hello there, welcome to my channel. My mission is to teach you AI so you can benefit from it in your work and in your life. I'm starting a new series called AI Mindset, and today I want to talk to you about the case for right sizing AI models. Let's take a look. So, for companies and teams who are just starting their AI journey, what they do is they select one model, they select one model and they use it for all their agents, for all their workflows, even for evaluation and testing, okay? And most likely they choose a frontier model, OpenAI or Gemini or or Claude, and they think that, hey, this is a big model, it's going to be accurate, and let's just choose one model, stick with it. The problem with that approach is over time, right, when they put their projects into production, what happens is the costs start to really go up. Okay, it goes really up. And also, if they have AI agents and it's a real-time use case, latency is impacted because these frontier models, right, they are huge, so the cost is high, the latency is high, and even customizing them is, it takes a lot of time and is expensive. Okay, and also then the problem is you have a vendor lock-in. So over time what happens is users and leadership, they are not happy, right? They complain, hey, the AI cost is too high, it's not delivering value. Like, for the value delivered, the cost is too high. Okay, AI projects are time consuming. Okay, people start to say, hey, we are spending so much money and it's not even accurate. It's accurate 95% of the time. It still needs human steering. It is slow, and there is overall, AI project disappointment with this approach, the one size fits all approach. So I want to present a case for right sizing. Okay, my take is teams and companies need to have a strong point of view. They need to invest time in the various models out there. Which models, what are the sizes, what are the strengths of those models. Invest time in learning about small language models. That is key. So let's take a look. Okay, so to right sizing strategy means using the most efficient model for your specific requirement. You have an agent has subtasks. You need to have a right sizing strategy for every task, for every place where AI is called. That's how you have to think about it. And these are the 4 ways you can have a right sizing strategy. Let's go into each one of them. Let's start with task specific models. So, based on your task, determine what level of intelligence is needed and then choose your model accordingly. If it's a data extraction task, for example, you need low to medium intelligence, go for a small language model. If it's a multi-model reasoning task, of course you need high intelligence. In that case, you have to go with a frontier model, which is specializing in multi-model reasoning. Okay, so based on your task, determine how much intelligence is needed and then choose your model accordingly. Match model size to complexity. That's point number 1. Number 2, have a SLM first approach. So go bottom up. Okay, go bottom up. So you have a specific task. First, try to determine if there's a small language model for that. If it's not there, then go up. Don't do the reverse. Don't go first frontier and then to the bottom. All right, because small language models are faster, cheaper, and they are optimized for specific tasks. Okay, and most of the time, for these kind of AI requirements, you don't need frontier models. As I said, this is a good visual. Small language models are small in size, they are focused, okay, and Microsoft has Phi, Google has Gamma, Amazon has Nova. Start with those, okay. Frontier models have knowledge about the whole world. They have voice, video, intelligence. You might not need all that for some of your AI requirements. Again, lot of benefits of using small language models. You can deploy them on premise for data privacy. You can deploy them on edge, on your own cloud, on your own Docker. Accuracy is high, you avoid vendor lock-in, latency is good, and they are very cheap. Very important. Fine tuning. So let's say you have there's a small language model, but accuracy is not too great. Okay, don't directly jump to a frontier model. You can add knowledge. You can fine tune the small language model via distillation or SFT, right? So you can add knowledge to it to improve accuracy. Fine. You can use a frontier model to distill knowledge to a small language model. You can add new knowledge using supervised fine tuning. You can add business specific reasoning using RLHF. So these are techniques where you have a small language model which is good but not good enough. You can make it good enough by fine tuning. Model optimization. Now you can take your SLM to another level. Okay, so you have a small language model, accuracy is great. Now you can make it a tiny language model without sacrificing any accuracy, right? Using two technical techniques called pruning and quantization. Pruning means you're gonna basically remove certain weights which are not needed and which don't impact the accuracy of your model. Quantization means all the model weights in the models are stored as 16-bit. You can make them 8-bit or you can make them 4 bits. So when you decrease the size of the weights, the model size becomes smaller without reducing accuracy, right? So this is one technical strategy which your teams should get proficient at, so that if you're going to implement AI at larger scale in your company, this is going to be really, really handy. It can save you thousands and thousands of dollars. Okay, so there are two papers I encourage you to read. Small language models are the future of agentic AI, and this one, from large to super tiny. Your teams spend time on these two papers so that you can right size models for your task. All right, so that's all I have. Hope you enjoyed. I'm gonna see you soon again. Bye.